So, good day students. Now we are going to see one of the important chapter in the NEET physics session, that is dual nature of radiation and matter. So, how the dual nature, what you know very well, dual means two. So, how the light possesses the two nature of the, what is the two nature of the light? So, that only we are going to see in the chapter, in this chapter. So, how light is important, who proposed the, how the dual nature of the light, radiation or light, etc., that we are going to see in the detail in this session. So, in this session, so this session is very important for this chapter of dual nature of radiation and matter, that is light which has a particle nature and wave nature. We will be discussed in detail. How the light got particle nature and wave nature is discussed in detail, will be discussed in detail in this chapter. So, dual nature of radiation. The dual nature of the radiation means we can take simple light. Okay. So, light if you take, it has the two nature. What is the dual nature? Which is light is a particle nature and wave nature. So, if the particle wave the moment particle nature means what it will have? It will have the mass m. The wave nature. So, the wave nature means it will be the various with various frequencies. So, how this how it has both particle nature and wave nature, how it got. So, everything we are going to discuss in this detail in this dual nature. So, in this now so for this scenario, first we go for the similar trend only, similar trendy, which is the so I am taking two elements, okay, which is having the one which is having only one electrons attached to this, having the force of attraction towards the nucleus. Now I am taking the another element which will have the lot of orbital shell, etc., with electron present in the with E1, E2. So, if I take this so number of electron present will be the number of electron, it has various shells. Okay. So, the outermost shell, what is here? It is innermost and outermost. Innermost and outermost, it's only one shell. So, innermost is also one, outermost also one. So, which is, so outermost equal to innermost, but here it is innermost is one. So, outermost is lot of innermost shell is there. So, outermost. Now, I am taking the outermost shell, outermost electron of the E1 and outermost electron of the E2. So, which will have the high affinity towards the nucleus, E1 or E2. E1 or E2. E1 or E2. Huh? I am taking two elements, E1 and E2. It has the first one, E1 is the electron have the high only one shell, okay, just only one shell. So, innermost also one shell, outermost also one shell, because only one shell is there. So, the affinity of the electron towards the nucleus. Now, I am taking the various shells, various innermost shells. It has various 1, 2, 3, 4 also you can put something around 4. I am having 5 shell, okay, 5 shell. Now, fifth one is the outermost shell. But here it is, first one is the innermost, outermost. So, 4 innermost here, fifth one is the outermost. Now, I am asking, each is E1 and E2. Now, I am asking that affinity of the electrons towards the nucleus in E1 and affinity of the electron towards the E2, which will be the greater? E1. Again you are lost. So, who is telling E1? Who is telling E1? E1. Okay, who is telling E2? Who is telling E2? E2. So, affinity of the electron of E1 to the things should be E1 should be greater than E2, because electron is outermost. Only the innermost shell will have the high affinity towards the electron. Innermost of the electron will have the high affinity towards the nucleus. This is what I am telling in the teaching in all the class. That means what I have to write? E1 greater than E2. So that's why. So E1 is greater than E2. Now I am supplying a no, okay. Now I am supplying a energy. Okay. I am supplying some energy. Okay. I am supplying some energy. Okay. I want to break the electrons of this E1 and E2. So which will consume more energy now? Which will consume more energy? Affinity of the electron, that is F1 is greater than F2, which is, that means F1 is greater than F2. Force of attraction of this one is greater than force of attraction of electron to the nucleus will be greater. So now which will now I am supplying the energy to break the electron from the nucleus. Okay, from the nucleus I want to break the electron. So which will consume more energy, which will consume less energy? So which will consume more energy? So how many people telling now E2? So how many people telling E2? Yeah, it's E1 because I need to supply energy. So I need to supply lot of energy to break this, which is the force one is greater. This one F1 is greater. That means so more force I have to supply this force F1. I have to supply more energy to break this force, which is F1. So F1, which having the attraction of electrons on the nucleus, will have the high force of attraction, that is F1. So I have to supply more energy to break this electron from the nucleus. But here it will be lesser energy or less force of attraction. Having the force of attraction to this nucleus is very less. So I need to supply energy of less energy compared to E1. So I have to supply. So for which one I have to supply more energy now? E1. So E1 is greater than E2 because F1 is greater than F2 because more force is there means I need to supply more energy, less force means less energy. So in this scenario now if you go for two things you can take cesium. Cesium has outermost electron. Cesium, if I want to break the electrons of the outermost, it will be 2.1 electron volt. But if you go for lead, which is lead, so it will be around 4.2 electron volt. That is which is outermost electron that is present in the cesium. I can easily break using 2 electron volt. What is electron volt? Electron volt is a total energy. Anything is a for total force the force in turn have the more force. So I am supplying to the cesium, which is 2 electron volt. In terms I am to lead. In the terms of lead, cesium and lead I am taking. Cesium and lead I am taking. Cesium I have to supply less energy, but lead I have to supply more energy. So if in the same scenario, so in the same scenario I am taking the cathode material and this one is the anode material. Light is falling on it. When any light I am taking now just now we discussed. For cesium how much I have to supply? 2 electron volt. Okay, approximately 2.1. Okay, 2 electron volt. For lead I have to supply 4. That means lead consumes more energy compared to cesium. So that means it has a high affinity or force of attraction. So here you can take anything, either cesium or lead. Okay, so I am taking the source of light, solar source of light or solar light, sunlight. You can put sunlight itself. falling on its cathode. Once it's fall on the cathode, any material when sunlight is fall on the photoelectric material, when fall on the light, what will happen? It emits the electron. Which electron it will emit? In the outermost shell. So what will happen? The electron will travel towards the anode. What is flow of electron? Flow of electron is current. When the electron flows here, immediately you can change, you can see the differentiation. You can see the flow of ammeter difference. Ammeter. What is ammeter and voltmeter? Ammeter, what is purpose? Ammeter is a one to measure the current. Voltmeter is a one to measure the potential difference. So the potential difference. Okay. So yeah. So now in this. So now two types of things. Now three types of things will happen now. So the photoelectric current. If the photoelectric current, I want to increase the current. So what will happen now? If that will be current will be increased. If I increase here the intensity. So the intensity that is if I increase the intensity of the light, what will happen? What will happen now? The current will also increase. That is, if I increase the intensity of the light, intensity of I1, I2, I3, the output of the current, which is here, which is current will be should be increased. Intensity I can take it as what we can take? We can take it as L1, L2, L3, something L1, L2, L3. The current output flow will be now I1, I2, I3. So now if I suppose that I3 is greater than I1, I3, not I3, L3. L3 is greater than L2, L2 is greater than L1. That means L3 has the highest intensity, L1 has the lowest intensity. So the output corresponding the current will be, which will have now? Three option RSS. Two option is there. I3 greater than I2 greater than I1. Second option is I1 is greater than I1, I2 greater than I2. Who is telling the answer? Two option. Wait, who is telling the answer? Who is telling the answer now? So two option I will give. I3 is greater than I2 greater than I1. Here I1 is greater than I2 greater than I3. So which is option A or B? Who is telling now? Who is telling?
Option A.
Who is telling? Option?
A.
I3 greater than I2 greater than I1, because intensity if I increases, corresponding the current will increase. Here the intensity increases, the corresponding current is decreased. So that's a B is wrong answer. So like that, if you increase the intensity, now corresponding set. So the electron, which is now once the sunlight itself we can take. Once fall on the cathode, what will do? The current, the electron will emit from the cathode. That is, electron will travel towards anode. That is, anything the electron flows, that means immediately the flow of charge, the flow of electron will constitute the current. So if I get the current, what I have to do? I have to apply the I have to stop the current now. What is I have to stop? This is the first. So when I increase the intensity, the current increases. So if what happened now? If I increase the voltage here, immediately the current flow will be reduced to or stopped. I want to stop current as a in current I, the current you can measure in ammeter. Okay, the current is flowing, that I can measure here, but the potential was there. Potential, I want to stop the flow of current. Okay, I am passing the first option is over. First experiment is over. Now we go for second experiment. Second experiment is, I don't want, but I am taking the sun. I am passing through the cathode. Once cathode is once the sunlight falls on the cathode, immediately the electron will flow out of the cathode and fall on the anode. Immediately you will get the current here. This is the experiment number 1. In the experiment number 2, what I am doing is, I don't want the current now, but I want to perform the same experiment. Because why I don't want current now, this second experiment 2, because I want to find out what is the minimum potential. What is the minimum potential to stop the current. So I am just in the experiment 2, same experiment as like experiment 1, I am performing the experiment number 2. Now I am going for, did you understand experiment number 1?
Yes,
experiment 1 we performed everything, current is flown here. Current is flown here, that once the moment current flows, that's all. Once the current flows, that's all, the circuit completes, because you got the current from the sunlight, you got the current here. But in experiment number 2, what I am doing, same thing I am doing it, but I have to but I have to show the current as 0. But once you know, right, once the current flows, once electron flows, you will get a current here. Now what I want to show current as a 0. So what I will do now, that's all. That is basically is experiment number 2.
Increase the voltage. Increase the voltage.
Yeah, increase the voltage. When I increase the voltage, automatically the current here will be 0. When I increase the voltage here, the current will be 0. Then what happened to the flow of electron here?
No flow.
Flow of electron will be there. The electron flow will be stopped. When I increase the potential here, I am increasing the potential here. When I increase the potential here, immediately it will become 0. Here the flow of electron will be stopped. The moment it is stopped means the moment here it stopped means obviously it will become 0, because no flow of electron. No flow of electron means the current is not flowing. The momentum of the flow of electron, everything is stopped, immediately stopped. When I increase the potential, the flow of electron is stopped. That is called stopping potential. So that means stopping potential means it is able to stop the flow of electron. So once it is able to stop the flow of electron, immediately the current here becomes 0. So that is the stopping potential. So the potential is the one that minimum potential that the minimum potential required to stop the flow of electron, or flow of current is the stopping potential. Did you take this? Huh? So now there comes the law of photoelectric emission. The photoelectric emission, just now we discussed, now in which topic we discussed? Huh? Oh, atoms, in atoms we discussed, no? Okay. Okay, so this, do you know that the electrons have the high affinity towards the nucleus, which is binding energy. So this total force of attraction is given in the binding energy. So I am supplying the external energy, which is solar energy or sunlight you can take. Sunlight I am taking, and to break the affinity between electron and nucleus. So if this binding energy we can keep as phi. Okay, so I need to break this force of attraction between electron and nucleus. First possibility is there. First one is what? If kinetic energy, if T is greater than phi, what will happen now? 3 possibilities are T greater than 5, T is less than 5, T equal to phi. So did you understand or not now? Okay, T is the total energy, sunlight, that I am supplying to break the binding energy. Binding energy is the force of attraction between nucleus and electron. Kinetic energy is the one, once electron is released from the nucleus, once electron is released that's kinetic energy. Kinetic energy is the Ke, kinetic energy of the electron. Okay, now 3 possibility arises. First is T is greater than 5, T is less than 5, T is equal to 5. If 3 possibilities substituted, what will they happen? First one I will go for first one. What is T? T is equal to 5 plus Ke. What is Ke here? Oh, kinetic energy of what? Kinetic energy of electron. Now first possibility. If the first possibility is T is greater than 5. If T is greater than 5, what will happen to the kinetic energy? What will happen to the kinetic energy? K is equal to K max. Maximum kinetic energy. How maximum kinetic energy? T K is equal to K max, because the kinetic energy is total energy is greater than 5. This is the 5. What is the 5? 5 is the binding energy. T is kinetic energy, means I am supplying the more energy, which is what more than binding energy. That is, I am supplying more energy that is needed to break the electron and nucleus. So the total energy that I am supplying is more than the thing. That means first it will break, total energy will break the electron and nucleus. Then rest of the energy by which the electron will travel in a once it's break, once the binding, once the force is broken, once you break the force between the electron and the nucleus, what will happen? The electron will try to eject from the once the electron will try to eject from the molecules, then electron will travel with the kinetic energy. So that is the Ke. That is the Ke. So kinetic energy K when K is equal to K max. That is electron will move with the maximum velocity. Electron will maximum velocity. Now second one is, what will K who is telling? Now what happened to the kinetic energy of the electron when the phi is less than T, and what is the kinetic energy of the electron when phi is equal to T? Who is telling? Any one person should tell. Who is telling? For second option. For second option is phi is phi is less than T. So what happened to the kinetic energy now of electron? Then what is it there? What is the kinetic energy now? Zero. It should be 0. Why it is 0? Because the binding energy, binding energy is the one, binding energy is the one that have the attraction of electron towards the nucleus. I am supplying kinetic energy which is less than this binding energy. That means the electron is not broken from the nucleus. K minimum, K is 0. Electron is not broken from the nucleus. Electron is not broken from nucleus. Electron cannot travel now with kinetic energy. So it should be 0. Because K is 0 means what? K is minimum is different from K is maximum. K is minimum means it's traveling with some velocity. Okay. K is maximum means it's traveling with high velocity. See, whether it's high velocity or low velocity, we don't know anything. But it's different from K is equal to 0. That means the electron is not ejected from the nucleus. Electron is not ejected from the electron is not ejected. Okay. Now T is equal to 5. Let us see at least who is telling this. T is equal to 5. Now what will happen to the Ke? Who is telling? We will see who is telling. Same. T is equal to 5. Now what happened to the kinetic energy of the electron? Again you throw the possibility, I have to pick the answer, okay? So who is telling? Kinetic energy will be what equal? Kinetic energy what equal? So who is telling? Any one person should tell. Any one person should tell. Who is telling? Who is telling? What constant? Yeah, it's 0. It's 0. K is equal to 0. Why it is k is equal to 0? Because I am traveling the, I am giving the total energy. Okay, total energy, I am giving the total energy to break the, total energy I am giving to break the binding energy. But this energy is utilized to only to break the binding energy of the electron between the nucleus and the electron. That's all. Now the kinetic energy, I need extra energy to travel. I already told you. I need extra energy to electron to travel. Extra energy is 0. Extra energy is 0 with respect to here. So there is no extra energy for the electron to travel. So phi k should be 0. So here k is 0, here is k is 0, here k travel with the maximum. I written as maximum. I didn't say it 1, 2, 3, 4. It could be anything. We don't know. We don't want also that. K is maximum velocity where it travel. Huh? Did you understand this?
Yes, sir.
Should I repeat once again?
No, sir.
Do you take this? ஆமாம் லாம்டா எக்ஸ் இல்லை லாம்டா எக்ஸ் வேறு லாம்டா வேறு இப்படி தானே இருக்கும் எக்ஸ். Now lambda de Broglie's wavelength. Okay, I want to calculate the wavelength. What is the wavelength that I am to? What is the wavelength? Just now we seen it. Okay, I am taking the sunlight or passing through the cathode. I'm passing through the cathode. Electron is ejecting from the electron. Flow of electron is the, what is flow of electron? Current. What is the wavelength? So what is that wavelength is called the de Broglie's wavelength. Okay, how can I calculate the de Broglie's wavelength? Is K is given by electron volt. Okay, K is equal to half mv square. So the is equal to p square by mv. That is how I got p square by mv into m divided by m. So I got p square by mv. So p is equal to root of p square is equal to root of 2 mk. Okay, K is, then I can substitute electron volt ev. So lambda is equal to h by p, which is h divided by this value if I substitute. K, how you got? K is equal, P is equal to root of m k. Okay, K, now K, what is K here? E electron volt. So if I substitute this value root of 2 m ev, now P is equal to root of 2 m ev. Now lambda is equal to h by p, which is h divided by root of 2 m k. So is equal to h divided by this K value 2 m ev. So lambda is equal to this. Now lambda is equal to 1.227 divided by
12.27.
huh?
12.27.
No, nanometer. No. Which one?
The
Last one. No. If you make all the substitution, you will get 1.227 divided by root k, root v. So root v if I substitute for 1 voltage, what is the value now? Lambda is equal to 1.227 divided by 1 nanometer. If it is 2 means, if it is 4 voltage means 4 means root of 4. Root of 4 is 2, which is 1.22 divided by 2. So it will be around approximately 0.66 something, or approximately 0.6 nanometer. If it is 9 means voltage is equal to 9 means root of 2. So it should be 1.22 divided by root of 9 is 3. So 1.22 divided by 3. So it will be approximately 0.4. So approximately 0.4 nanometer. That means if I increase the voltage, what is showing that correspondingly the wavelength will?
Increase.
No, wavelength will change. It's just different, increase or decrease that we want. If I increase the voltage here, corresponding the wavelength will change. So the wavelength is something directly depend upon voltage. So that means the voltage difference is the wavelength is directly depend upon inversely proportional to voltage, and is independent of current. Is independent of current. Is inversely proportional to voltage. So if I increase the voltage, what will happen?
Decrease in wavelength.
No, that's different. No, that I don't want. This is independent of it's depending upon the voltage, whether it's directly or indirectly, and it's independent of current. So whatever the current flows, it is independent of the wavelength of the electron. The wavelength is not dependent upon the current.